Hello SL2, this is Mrs. Moore. Today's topic we'll be speaking about is trig identities. And the first trig identity I wanted to talk about today is cosine squared theta plus sine squared theta equals 1. It's probably one you're very familiar with, but I just wanted to make sure everyone understands the background behind this. We're going to be using the unit circle and Pythagorean theorem to help us remember why this is a true identity. So first let's remember the Pythagorean theorem. It's a squared plus b squared equals c squared. And this can only be used with right triangles. So if we have a right triangle, just remember that a is a leg, b is another leg of that triangle, and then c would be the hypotenuse. Then you want to take a look at our unit circle and be thinking about our point that goes around the unit circle. If it starts off at 0, our cosine would be 1 and our sine would be 0. Let's first take a look at approximately 30 degrees. If we were to look at that point with 30 degrees, we would be using this as a reference angle here. This right here would be our hypotenuse of 1, and then we would have 30 degrees of our angle. Let's move this triangle over here and just talk about this part. Let's say that is 30 degrees. Alright, if that is 30 degrees and this is our right angle, let's go ahead and use and help us remember the 30-60 right triangle. The way I remember it is I always remember that the square root of 3 is across from 60, and then I know that 30 then would be a 1 would be opposite of 30, and 2, the hypotenuse would have to be bigger, so 2 would be the hypotenuse. And then to make this as a unit circle, I would have to make our hypotenuse to equal to 1. So then I would divide each side by 2 and to make the hypotenuse a 1, and our sides would be opposite of 30 would be 1/2, and adjacent to 30 would be a square root of 3 over 2. So in that case, our cosine would be the adjacent, would be square root of 3 over 2, and our sine would be 1/2. If we look at the picture of this, we can see again that how this works with our unit circle. The cosine is our x value and the y is our sine value. If you look at how this program use the Pythagorean theorem to solve this identity, they also used sine 30, and they took sine 30 squared plus cosine 30 squared to equal 1. Well, sine 30, just like we said, would be the opposite, and that would be over the hypotenuse, and that would be 1/2. So 1/2 squared would be equal to 1/4, and then they simplified 1/4 to 0.25. Then they took cosine of 30, which is the square root of 3 over 2, and squared it, which would make it the square root of 3 squared over 2 squared, which would be 3 over 4, which would be equal to 0.75. I probably would have left each one as a fraction because IB doesn't take off. They will take off if you don't simplify correctly, and it's as proper as a fraction. So I would have left it as 1/4 plus 3/4, and that would equal 1. Either way is fine, and just fractions are a good thing to keep in mind for the IB exam. So for the second identity, we're talking about tangent of theta equals sine theta over cosine theta. We can use this same identity to talk about to show where we are on that to prove that. It's not exactly a proof, but it'll help you just make sure you frame it in your mind. So if we use tangent of 30, the sine of 30 again would be 1/2. The cosine of 30 would be the square root of 3 over 2. To find the tangent of theta, we would want to take 1/2 and divide it by 3, square root of 3 over 2. And just to practice our algebra here, remember when we're dividing by a fraction, we'll multiply by a reciprocal. So our reciprocal of square root of 3 over 2 would be 2 over the square root of 3, and then we can cancel and we get the tangent of 30 degrees to be 1 over the square root of 3. Okay, our last two identities are the cosine 2 theta equals 2 cosine squared of theta minus 1, and sine 2 theta equals 2 times cosine theta times sine theta. Let's look at number 3 and this identity here and prove that one. This one will be more of a traditional proof than the last ones where I was showing. So let's take a look at a bigger diagram. We have, so we're trying to look for, anytime we have to prove something, we want to make sure we set up using the problem. Okay, so let's use an isosceles triangle to prove this identity of cosine 2 theta equals 2 cosine squared theta minus 1. And I'm going to go ahead and type in, because I think it'll be faster than using the pen. And let's just start by saying ABD, our isosceles triangle here, is an isosceles triangle, and this side is length is 1 and this side length is 1. Therefore, this angle theta is the same as this angle theta. And we're going to go ahead and call that theta. Okay. Our angle of DBC, and we can create a straight line down here. That would make BCD a right angle. So then we could say our angle DBC is an exterior angle, and the sum of the opposite of two interior angles, therefore it would be our 2 theta. So let me type that in. Okay, so now we have our, we're going to trying to prove this cosine 2 theta. So now that we have that this is our 2 theta, let's see if we can set up some relationships to help us solve for that and get to cosine squared theta. So first let's look at cosine 2 theta, because that's what we're looking for. And let's see if we were set up that relationship with 2 theta. Remember that cosine is adjacent over hypotenuse. So our adjacent here for this triangle, for our angle DBC, would be BC would be the adjacent and BD would be the hypotenuse. Okay, and we know that AB is 1 and 1 unit and BD is 1 unit, so that we can say our BC over 1, because BD is equal to 1. So our cosine 2 theta is equal to BC. Here we can look at cosine theta. And we can also make a similar argument. Let's go ahead and move that up. Our cosine theta, if we use this side, this theta, would be, we would have an AN if we cut this in half and made 2 right angles. We can call that point N, and we would have AN for this cosine, that would be the adjacent for this triangle, over AB, that would be the hypotenuse. Again, that AN over AB would end up simplifying to AN because AB is also equal to 1. Okay, so similarly, ND would also equal to cosine theta if we were to do that same relationship with this angle. Now remember where we're trying to go with our equation that we're trying to uncover, and we know what cosine 2 theta is. We need a cosine squared theta. So we're going to try to set up a relationship. The first one is looking at our AD here, the longer angle. So AD would be equal to 2 cosine theta, and cosine theta would be equal to AC over AD. So let's look at why AD is equal to 2 cosine theta and cosine theta is equal to AC over AD. So the first part is, if you look at the AD, you can see that AD is the setup of AN plus ND. And since AN is equal to cosine theta and ND is equal to cosine theta, we can say that cosine theta and cosine theta would be 2 cosine theta. Then we can also look at cosine theta in the relationship of this entire triangle, and we can say that it is AC, that would be the adjacent, using this right angle, over AD, using that hypotenuse. So that relationship also exists with the bigger triangle. So now we have some items that will help us solve the identity, and let's go ahead and start off with this cosine theta, AC over AD. Okay, so there's only a little bit more of relationships, and then the rest will be algebra. So on the next video, I'll finish off this problem and talk about a couple other right triangles, how to solve them.